Hello guys, welcome to the session. So if I'm audible, just say hi or hello in the chat so that I can get get a confirmation from your side. Yeah, okay. So I think yeah, I'm audible. So we'll be starting our session just in a while. So I'll be starting in a while, in just a minute or so. Yeah, so and before starting, guys, I would like to remind you that for this webinar, you all will be awarded participation certificates from AWS Educate, and newcomers will also get $100 credits, right? So be with us till the end, guys, and I'll be sharing the Google Form link in between of the session in the comments. So I think let's start. So, my name is Kshitij Verma, and I'm Computer Coding Head of CodeChef-VIT. And today I'll be taking your session on Introduction to Cloud Computing and AWS, that is Amazon Web Services. So, first of all, let's uh, let's look at the flow of the webinar, like what all we would be uh, doing in this webinar. So first of all, we'll get to know about the what's cloud computing. We'll have a quick introduction to cloud computing. Then second, we'll discuss about all the cloud models. Then the main thing which is I'll be introducing you to AWS, and at last we'll be discussing about its domains and services, and we'll also be uh, practically seeing and launching some of the services at the end, right? So this is all in a nutshell we'll be doing in this webinar. Moving forward, so what's cloud computing, right? So cloud computing is nothing but the use of remote servers on internet to do a particular task. But then it comes like, why do we need to connect to remote servers, right? So just imagine you have an application which requires a lot of processing, right? So what will you do? Will you buy a server which has a lot of processing power? Or if I give you an option that you can rent a server from a cloud provider, right? And then connect it via SSH and put your application into that and run it. Plus, the moment you are done with the server, you can give it back and you'll only be charged for the time period that you have been using it. Okay, and that too at a very low cost. So, isn't that amazing, right? So, this is what cloud computing is in a nutshell. Now, okay, so now let's see how the cloud computing came into the picture, right? Because before starting, we should know like how it came into the picture. Now, again, imagine you are a developer. Okay, you are a developer here, and you you made an app or a website. Say this is app, or you made an app and or a website, and you want to make this available over the internet. So what you can do traditionally is you can buy some servers and then put the application over the internet, and then people can come visit and start using your web application or your apps and all. But what the problem here is, first of all, you need to buy all these servers, which are not cheap, and we are talking about a stack of servers because let's say we are talking about a production grade, like for a startups and all. Also, at the beginning stage, you don't even know like whether your app or website is going to be a success or not, right? And the second thing is, you need to connect servers and all of this. You need to connect servers and all of this manually, like buying static IPs, domains, etc., etc. And and what if like the number of users, like your application becomes famous and more number of users visits your servers. So then again you need to buy more stack of servers and again repeat all of this manually. So all in all, this whole process is a very tedious one, right? So what instead of this, what we could have done is like now let's see how we could have done this via cloud computing. Okay, so I have the application with me. Okay, I have the application with me, and I'll go to AWS. I'll launch a stack of service and I'll put my application over there. Then what AWS does is it automatically gives me a static IP address, and it has a service which will give me domain name as well. So like earlier, I don't need to buy static IPs, domain, etc. All of this is AWS headache. Okay, and then I would just configure my domain. I would just configure my domain name to connect this to the IP address, right? And I'm done. That's it. I don't even need a team. I don't need to manage any of these servers, right? So, like till now, what I have explained, through that you can very well see that it's very easy process, and it's a very feasible one to use cloud computing, right? So next, like what are the advantages of cloud computing? The first thing is uh, there is little or no investment because you don't have to buy a stack of servers. You can just simply rent the services at a low cost, right? And the second thing is you can focus more on the development part than worrying about other stuff like how is the traffic coming to my app or website? Is my infrastructure scalable enough? Is my infrastructure scalable enough to handle the traffic which is coming to it, etc. And the last one is it requires less workforce. What I mean by less workforce is there is no need for the like since there is no need for the hardware upgradation or any security patch, etc. Because it's all the headache of the your cloud service provider, right? For let's say AWS. So it's all the headache of the AWS, not ours. And that is why most of the companies today are also using cloud computing, and particularly startups, right? They prefer their servers to be on clouds because obviously when you are starting out a new company, you have a very limited amount of money to invest in it, and cloud computing saves a lot of your money, and that is why nowadays many new companies are also coming out. A lot of people are trying out their own apps or websites to provide to a particular service, right? So moving forward, because cloud computing is so huge, there are a lot of products which are available on cloud these days, right? And you don't even know whether they exist in cloud or not. Say, for example, Netflix. Netflix is the biggest example that everyone is probably using in their life, especially this lockdown, right? And its entire infrastructure is on AWS. Everything everything from A to Z, their scaling part, their content delivery network, security part, everything is handled by the AWS. Now, why such big companies are relying on infrastructure of cloud providers, right? The reason is that their services never go down. I'll give you one example. Netflix suffered a huge blackout on internet in around 2008, where all the servers were down because more number of users came up to use the service, and that's when the servers crashed, because of which Netflix suffered a huge loss. Right. So then Netflix started to migrate itself on the AWS infrastructure, and now we rarely see that Netflix services are down, right? We rarely see like the its services are down. And Netflix is just one example. Other businesses like Amazon e-commerce website is also hosted on AWS infrastructure. Okay, so now imagine you are sharing the same infrastructure which the biggest e-commerce company in the world is using. So you can be rest assured that your application is in safe hands, right? And another great examples are LinkedIn, FB, BBC, Prime Video, etc. Okay, so yeah. Now let's talk about cloud computing models. So cloud computing is basically divided into two kinds of model. The first one is deployment model, and the second is service models. Furthermore, the way you can deploy on cloud has three ways to it, right? You uh, Three ways to it, and the way you can access these services on cloud, like these are public cloud, private cloud, hybrid clouds. Okay, so now let's understand all of these things one by one. All of these what is public cloud, private cloud, hybrid cloud, infrastructure as a service, platform as a service, and software as a service, right? So starting with the deployment models, we can first see like public cloud. Now, what is public cloud? Public clouds are the servers which are offered by a cloud provider, in which each server can have multiple companies hosting their application. All right. So why is there segregation? Right. Although there is no problem when there are multiple applications on the same server, but what happens is some companies are still skeptic, and some have data policies that they say, uh, we have confidential data and we cannot take any risk where some other company is also on our server, and there's a risk of our data being hacked into, right? So that is why different deployment models are created. Okay, and the next is private cloud. So what is private cloud? Private cloud can be two things, right? The first thing is like I said, if you want a separate server all for your yourself, where you say no matter how much space is empty, and no matter how much of the server is free, I just want my data to be isolated, right? So that becomes a private cloud. And the second way of creating a private cloud is you buy your own servers and you create your own cloud in your data center, right? That is, you buy all the stack of servers required and you host your application as if you are hosting on a cloud provider. And it's just that it's your own cloud that you have created. So in that way also you can say that it's a private cloud. Now the third one is hybrid cloud. Uh, Now, what is hybrid cloud? When you want a kind of infrastructure wherein you are using some of the public cloud and some servers from the private cloud. In that case, it becomes a hybrid cloud. So let me give you an example. Let's say there is a research company and its marketing website exists on public cloud. Okay. But on that marketing website, people have the access to log in, and when they log in, they can see their research materials that they are working on. Okay. But this research material does not exist on the server of the public cloud. It exists on some other server which is private cloud. Okay, so from a user's perspective, what I'll say is it's that everything is on the same website, but actually the infrastructure is like that, that my research files are on private cloud and the website that I'm hosting is on public cloud. Why? Because it doesn't have much of the confidential data. That's why I can host my website on a public cloud. So this is a very fine example of how a hybrid cloud kind of architecture is. Okay. Now moving on to our next topic, that is service models. So so far we have discussed the various ways in which I can deploy my application. Right, one second. Yeah, yeah. So far we have discussed the various ways in which I can deploy my application on a cloud provider, and now let's discuss the various kinds of services that I can uh, that I can get from a this service models of cloud provider. So basically, there are three kinds of service models that we get in cloud computing. The first one is infrastructure as a service. In this, basically the cloud provider will give you an access to the server. That is, you will get an access to the OS of the server, and you can install anything you want on that server. So what you'll get a OS and then OS of the server, and then you can install anything you want on that, right? You can either make it a database server or a website server. It can become anything. Whatever you want to do with it, you can do that. So basically, when we say infrastructure as a service, you are getting the whole infrastructure and you are getting the whole system, you are getting the whole virtual machine as a service delivered to you. All right. And the second Yeah, and the second is platform as a service. It is contrary to what we got in infrastructure as a service. Here, I don't get access to the operating system, but what I do get is kind of like a dashboard, right? As you can see here, I'll show you that in practical also. Wherein in that dashboard, I can upload any files that I want, and those files would automatically be put on the server by AWS, and I can see those files hosted on the server. So, right, so that's all platform as a service does. So to make it clear, let's take an example. Okay, suppose I want to set up a website and I get is infrastructure as a service. Okay, so in that case, what I will have to do is get a fresh operating system, then install web hosting software like Apache. After that, I will have to do an FTP or transfer my files from a local computer on that server, right? And once I have done that, I'll have to put those files in a specific folder on that particular server, and only then I'll be able to access it when I go to the IP address of that particular server. Whereas, like in the case of platform as a service, right? Whereas in the case of platform as a service, what happens is that I'll not get access to the OS, and all the software settings that are required are done by the AWS only. What I do get is an access to a dashboard where I'll have a button called upload. Okay, and I'll click on that upload button and upload my website, and automatically it will upload it to the right location. It will give me required permissions. So that's so that my website is hosted. So as a user, I don't have to know what kind of and which version of software has to be installed, etc. Basically, you can say that it's an automated version of infrastructure as a service where you get specific access on the server. Okay, then moving on to our third service, that is software as a service. In this service, what you right. In this service, what you get is a software which has already been hosted in the cloud, and that software you can use. Okay, like I'll explain it by example so it would be more clear. For example, like Netflix. Okay, Netflix is a software, correct? And it doesn't matter which software it doesn't matter which server it is on. It doesn't matter whether you upload your files or not, right? But you can use the software which is hosted on the cloud. That is software as a service. Other examples are like Google Docs, Google Excel, etc. So this was all about cloud models which exist and which are offered to the customers. Okay, now moving forward, let's uh, let's talk about cloud providers. Now, whatever we have discussed so far is generic to cloud computing. Okay, these kind of business models that we discussed have adopted by various companies which are out there, say AWS, Azure, etc. So we'll be saying this. Okay, so the companies like AWS, so companies like AWS is there, which is the most prominent one. Okay, the second is Microsoft Azure, and then you have the Google Cloud, and there are 100 plus more companies which give you the same kind of services like DigitalOcean. Just the terminologies are different, but at the back end, it's doing exactly the same thing. Okay, so why I have mentioned only these three companies here, right? It's because they cover almost 80 to 90% of the cloud paradigm right now. Okay, and in this session we'll be discussing only about AWS, right? So next is like why AWS, right? The first reason is uh, the first one is like AWS owns 35% of the market share in cloud computing. That is, if there are 100 companies which use cloud computing, out of them, 35 companies would be using AWS, right? The second reason is AWS was way back incepted in 2006, And since 14 years, AWS has been running cloud computing business. And when AWS launched its cloud computing business, it was the first and the foremost cloud provider. Okay, and that is the reason for such a huge market share of AWS. And Azure and Google Cloud are nowhere near it. And also the reason behind it is, like I told you, the first cloud computing business was of AWS, and it came in 2006, and it took almost 7 years for a competitor to respond. That is, Azure came in 2013, no, 2012 around, and in the next year, Google Cloud came. So till this much time period, AWS was ruling alone. And the third reason that why we are learning AWS, or why you guys are learning AWS today, is because of the job opportunities. Right. So because it has a greater market share and more companies are using AWS, obviously the job opportunities for AWS are also more, right? When you compare it with the counterparts, that is Azure and Google Cloud. So again, if 100 companies are there, and out of them 35 companies are using AWS, that means 35 companies you can apply on, right? To become the solution architect, or to become a AWS developer, etc. So it's always better if you want to get into the cloud domain, to first get to know the major player, right? And then you can learn Microsoft Azure once you have understood AWS, because they are almost the same. All of them are basically same services, just that the terminologies that they use are little different. And the last one is, reason is, it's the fastest growing public cloud in the world, right? So since now we have understood that why we are learning AWS today, let me introduce to you what AWS is, right? So AWS is basically a subsidiary of Amazon.com, which is largest e-commerce company in the world, right? So the way Yeah. So the way AWS came up in the market was that Amazon was building the infrastructure for its website, and they have designed an infrastructure which was highly scalable and highly available, and it can auto scale itself, and it can downscale itself too. So all of these things were part of their architecture of the Amazon website. Now, when they created an infrastructure like that, like this, they thought, why are we only using it for our website? Why don't we make it available to general public, and they can use it as long as they want it in a pay-as-you-go model, right? And that's how the cloud computing business came into the picture. And now today it offers services in compute, it offers in storage, networking, management, and security, and many more. And that we are going to discuss as we move along. Okay. Now the next is service domains in AWS. So AWS provides its services in compute, storage, database, security, management, customer engagement, app integration, etc. Okay, now let me explain each of these domains one by one. Okay, yeah, right. I would like to guys, if you have any doubts, so you can type it in the chat, and also I'll like to repeat that. uh, that for this webinar, you will be awarded participation certificates from AWS Educate, and newcomers will also get $100 credits, right? So be with us till the end, guys. Be with us till the end, guys, and I'll be sharing Google Form link in after a few minutes, and then you can fill out that. Okay. So so I see like there are no doubts. So let's move. Okay. So I'll explain you these domains one by one. So the first one is compute domain. So compute domain basically deals with servers. So if you need server, or if there is a workload which needs processing, the compute domain will have services that you can launch and implement that workload. Okay, then you have this storage domain, which stores binary files on remote servers. And what are binary files? What I mean by binary files are like video files, images, etc. Okay, so for that we have a dedicated service of storage. Okay, in AWS. Then we have a domain called database. It has a lot of services. So if you have structured data, then or if you have a structured data, you have this one kind of service for that. If you have unstructured data, you have another database service for that, right? Then we have domain called security. So all security related to the application that you have uploaded, to the servers that you are using, to the account that you are using. For all those kind of things would be included in this security domain. Okay. Then we have the management domain, uh, which uh, which will include like monitoring, which would include deploying the whole architecture at once, right? All those kind of services come into management. Then we have customer engagement. Okay. So sending emails, sending notification, all these kinds of services come under customer engagement. And in the end we have app integration. So services like use, like for example, if you have an application on which you have to give a lot of jobs, it's better to have a queue where you will store all your jobs, and once that queue is separate from the server which will be executing your jobs, right? So these kind of integrations are called app integration. So these were the main domains that are there in AWS, guys, and there are a lot of other domains as well. And moving forward, now we'll be discussing few services like EC2, Elastic Beanstalk, AWS Lambda, Elastic Load Balancer, auto scaling, ECR, ECS. Okay, and then we'll practically try out some of these services too. Okay, now let's start with our first service, which is EC2. Okay, so Elastic Compute Cloud is nothing but a raw server. It's just like a fresh computer that AWS gives to you. Okay, so what you basically do is you specify the kind of processor that you want. You then specify the kind of RAM that you want, and then you click on launch. And what happens after that is you get a server which is basically on that exact configuration. Okay, and then you'll have to connect it. So like once you have configured, you need to use that configuration, right? That service, right? So then you will have to connect to it remotely. So if it's a Linux machine, you will connect through SSH. If it's Windows machine, you'll connect through RDP. And once you connect to it, it will give you the UI of how an operating system actually is. Okay. And I'm also going to launch EC2 instance in a short while, so it would be completely clear to you guys then. Okay, and before that, let's discuss all the other services which I mentioned earlier. So as I told you guys earlier, EC2 is a raw server, so you can install anything, you can make it anything. You can basically make it a web server, you can make it a database server. It can be anything, right? Now in this diagram, as you can see, uh, you can launch either a single EC2 instance or you can launch multiple EC2 instances. You also have an option of creating an EC2 instance and then installing some softwares on it, and then you can launch multiple copies of that particular EC2 instance, so that you don't have to launch, or you don't have to install all the softwares all over again, right? And you can create multiple copies of the EC2 instance again and again. Okay, and at some point of time, if you feel to increase the configuration of your system, you can also do that, right? And that is why the name is Elastic. Okay, Elastic Compute Cloud. Elastic means that you can increase the size of the instance or decrease it anytime you want. Okay, now the next service is Elastic Beanstalk, right? Elastic Beanstalk, you can say, is an advanced version of EC2. And how it is an advanced version of EC2? In EC2, what we could do was, uh, we can just launch a server, right? And then you can install softwares on it, etc. But in Elastic Beanstalk, you get certain restriction on EC2, and there is a certain amount of automation involved to it. Right, I'll explain you what it is. And basically, Elastic Beanstalk is a web application server, and you cannot install any other software on it. It's a web application server on which you can upload your website, and you don't have to install any software or anything else. And we talked about what is infrastructure as a service, right? And what is platform as a service. Okay, so infrastructure as a service is EC2. I'll repeat. Infrastructure as a service is EC2. Okay, where you get whole server, you get the access to the operating system, etc. Right. Whereas, and this Elastic Beanstalk is a platform as a service. So in this, you get is a dashboard, right? As I explained you earlier, in platform as a service, you get only a dashboard. So in Beanstalk, uh, you all you get is a dashboard, and you don't get the access to the operating system, etc. Everything is pre-configured, right? And all you do is you say that I need a PHP server. It will launch a PHP server and will give you a dashboard where you'll have a upload kind of button, and you click on that button, and you'll have to upload your website over there. So once you have uploaded your website files, they automatically go into the path where they have to go, and all you have to do now is go to that IP address or domain name of that particular Elastic Beanstalk instance, and you'll be able to access your website. So I hope you would be clear now that why I said it's an automated form of EC2. Right, and that is why Elastic Beanstalk is called automated version. Okay, but there is a limitation that only it can be a web application server. Okay, you need to remember that this limitation, that it can only be a web application server. Right. So Akshat asked me a doubt. that can we run multiple different applications in the same EC2 instance? Yeah, you can definitely run it. Like I said, uh, application you can run different applications for sure, but to make it as a particular server, you can either make it a database server at a time or something else. But you can run multiple applications in the same EC2 instance. It's you can do anything with that, right? So I hope that's clear. Now, our next service is AWS Lambda, and AWS Lambda is automated version of EC2. It's an advanced version of EC2, but with some restrictions, like you cannot upload your website to it, and it cannot host an application for you, like the previous two services used to do for you, right? Which we discussed right now. So so what AWS Lambda does it is basically just used for doing your backend processing. For example, let's say you have an image processing application and you have a website through which you can upload the images, right? So you have this image processing application, and to upload the images on that, you have a website for it. And what that website does is it stores the image on its storage, and then it reduces the size, and then you can download it again, right? So now you might be wondering that why like why this is one website that this is one website, all of this is taking place on a single particular website. And so ideally, it's right that everything should be happening on one server, but this is not the case here. So what happens is your web application is on a separate server and the processing happens on a different server. I'll tell you and AWS Lambda specializes in the processing part. So that processing part would be taken care by the AWS Lambda. Okay. Now, why AWS Lambda is preferred for processing is because when you launch a server, you have to select the configuration that you want. You have to select the processor, RAM. But with AWS Lambda, you don't have to specify any configuration. You don't have to choose what services should be there for my application, right? And so that it can handle the workload coming into that. So all of this, you don't have to do that with AWS Lambda. So what AWS Lambda does is it sees that what kind of workload is being given, and it automatically scales up if it has to, like in terms of its configuration, and then executes on your workload and gives the result to the server, which is the web application, right? Which for the image processing application server, where it has to give the result on the website. You have to give it the reduced size of the image, right? So basically, only processing happens on AWS Lambda website, and deployment happens on the Elastic Beanstalk, right? Now, I think let's discuss about what's Elastic, about our next service, which is load balancer, Elastic Load Balancer. Okay, so whenever we create a production grade application, we basically deal with distributed computing, right? So when we talk about distributed computing, we also have to talk about redundancies. Okay, so that my application is highly available, right? And now what that means is, imagine these three servers are are your web application servers. Okay. Now, if you had just one, if you had just this one, uh, in that case, what will happen is if there is any kind of fault in this particular server, my application will go down. So, so what I'll do is I launch the exact three copies of that server. Okay, and what happens is in that case, if one of the server goes down, if say this server goes down, my user can view my website on the other two servers. Okay, and if both of these servers go down, then you can view on this server, right? But now you might be wondering that say how will the user know which server to go on, right? And that is exactly what elastic load balancer is all about. So what it gives you is one domain to go on. It will give you one IP address to hit on, and when you hit the IP address, the elastic load balancer will automatically analyze where to send the requests. Okay, so it will automatically analyze whether to send the request on this server or on this server or on this server according to the traffic. So it constantly keeps a check on on all the instances which are running in your cloud environment, and it sees which of them are healthy and which of them are unhealthy in terms of the traffic I am considering. Okay. If there is a server which becomes unhealthy, what your load balancer will do is it will stop routing traffic to that particular server and start routing to your another server, which has less traffic on it, right? And this is the main job of the elastic load balancer, okay, which is to distribute traffic among all the healthy instances which are out there. Also, another important thing about load balancer is it will never make one server max out on its performance, right? Because it will continuously distribute the traffic among all the servers so that the processing overhead on any of the server doesn't go up. Right. And so how Elastic Load Balancer does all of this is like I told you, it will constantly keep a check on how much traffic is coming on my website, and accordingly uh, it will uh, it will uh, ro- like uh, transfer the traffic over my servers. Okay, so all of and this part is this part we call is auto scaling, right? So auto which we'll discuss in which is our next service, that is AWS of AWS, that is auto scaling. So what it does is it automatically scales up the number of servers. It automatically scales up the number of servers based on how much traffic is coming to these servers. Okay, now how it does that is suppose you can set a threshold, like whenever the collective CPU usage goes beyond 80%, launch one more instance. Okay, and the load balancer will now route the traffic to this new instance as well. Okay, and similarly, here as you can see in this diagram also, when the collective CPU usage is below 40%, then decrease the size of my servers. Okay, and therefore we can say that auto scaling service cannot exist alone. It will always have to work along with the AWS load balancer. They go hand in hand. Okay. Then our next service is ECR. So, which is Elastic Container Registry. For this, guys, you have to know what Docker is. Okay. So, if I have to give you a brief about what Docker is, it basically is a tool. It basically is a tool using which you can launch operating systems in the minimum size possible. So earlier we were talking about distributed computing, right? In that case, we saw each of our server uh, plays a different part in our application. So similarly, what we can do is we can launch containers. Now that containers what that containers do is they act as a virtual server, but they can take the minimum resources, but they take the minimum resources possible, and at the same time, minimum space possible. So in these containers, you can deploy applications, okay, and these applications then these applications run as if they were running as a separate server, okay, and you can also understand it like it's basically a mini virtual computer. Okay, I'll say it again that it's basically like a mini virtual computer that you can run it in your system. For your understanding purpose, you can understand it like this also. And what ECR service does it? It stores these containers in a repository. Okay, like we have GitHub, right, to code. Similarly, we have ECR for storing the container images. Now if you want to run those images, you have a service called ECS, which on AWS. So what ECS does it runs any Docker image on the AWS infrastructure, right? Like whichever you would be creating with the ECR, you can run it via ECS infrastructure, right? And it orchestrates in a way that if there's anything wrong with that container service, then that container service uh, can again be launched. So it will try again and again, right? Now, don't get confused with what we do in EC2. Okay, it's a bit different. As we have as you might have a question that in spite of launching EC2 instances. Okay, now let's understand it like in spite of launching multiple EC2 instances, why don't I launch multiple containers? Okay, but in that case, what will happen is you are still like you are still using the machine on which the containers are running, and that becomes the node point of failure. So if that machine goes down or something, so whole of this setup uh, would uh, would would be a failure, right? So uh, so I think that's enough of the theory, and accordingly you'll be getting your certificates and credits, $100 credits. Okay, just a second. So to create an account, guys, you need to go on aws.amazon.com. Wait. Okay, and once you visit this website, uh, you can click here, complete this sign up. My net is right. Wait. to create an account. Right. So you just go to this create an account, fill out your email address. Okay, fill out your email address and say abc@gmail.com, password anything, again, then say name, account name, then continue. I'm just giving a random email address, guys, and to show you. And one thing is there that the amazing part about AWS is you get 12 months of the free tier access, right? You don't have to pay a single dollar to use the free services provided by the AWS. Okay, then say we are using a personal account, provide your phone numbers, right? Phone number, country details, address, city, and all of this. And say, once you click here, create account and continue, then it will ask you for your card details, and you just need to enter that for the verification purpose. It won't charge you anything, and then you will have free services for the next 12 months. Okay, so now let me sign in and quickly show you and launch some of the services. It's taking a lot of time. Okay, so I'll put out my email address and then password. Right now, After that, guys, from my account section, click on the AWS Management Console. Okay, now here you can see that I have all these different services which are provided to me, which comes under different domains like compute, machine learning, container storage, analytics, database, all of these. But for today, we'll only be discussing about the basic services, and we'll only be launching some basic ones. Let's start with EC2. uh, right? Click on the EC2. As you can see, there are a lot of options on the left. So don't worry about each of these options. For now, we'll just understand how to launch an EC2 instance. Okay. So just click on this various operating systems. You can select any one of them from the following. Like you have Red Hat Enterprise Linux 8, and you have Ubuntu servers with you. You have Windows, and right. And but always remember, guys, to choose from free tier eligible services only. Uh, for that, you won't be charged anything. Otherwise, you'll get charged for using other services. Right. So let's say I'll run select Ubuntu as my operating system. Then we have here various options based on the CPU and the memory size. And but the only service which is instance available to us inside free tier is this one. So we'll go with this, and which is enough for now. That is one CPU and 1 GB is enough. Next, configure instances. Okay, and just for now, just click on next. You don't need to touch any of these. Leave it as it is. Then here it asks you for this. Like it will give you like how much RAM, sorry, size. What's the size would be there for your Ubuntu operating system. So for now, let's keep it 8, or you can change it also. You can make it 16 or anything. And we'll next click on add tags. So what basically add tags here does it, like like suppose we add the tag over here as CS department, our IT department, etc. We'll create one tag and we'll name it like department and categorize into IT department. And so when somebody is searching for for all from all the instances, and I need to just get the details about the IT department. So what I'll do is I'll just type in department equals IT. Okay, and it will give me the list of the instances which are available under that tag. Okay, so we don't need to add tag for this demo. We'll for right now, and we'll click on next. And here you have the different protocols with you, which you want through which you want to allow your server, through which you can connect also on your device. So these are various protocols are there. SSH, okay, SMTP, DNS. We'll put SSH. We'll Then we have source. So what source here means is like who can connect to this in this service or instance. Whoever have my IP address, like anywhere means anyone can access my this instance, or custom I can add the specific IP address, and only that system would be able to log in, access my instance or my IP. That means only this system would be able to use this service. So basically I'll give it anywhere, so that like if anyone wants to connect, like if I'm using it in my this laptop, if I want to use in my another laptop, so I would be able to do that. So I'll click on anywhere and just review and launch. Okay, so in here you can review all the details. Like for security, you have selected SSH and protocol is TCP. This port number is 22, and anyone can connect to it, right? And then we'll click on launch. So now what right? And now what this key pair does is it adds a security layer to the servers, to our servers. So that not everyone with the IP address can directly connect to it. Like since I've selected in that that anyone can connect, since I've selected anywhere in the source, so anyone would be able to connect to this IP address. But at the second stage, it will ask for an key pair authentication. So it will give you a key that you have to use while connecting to the instance. So suppose let's create a new key pair. We'll name it as test 2, and we'll click on download key pair. Okay, and I'll put it on my desktop, and as you can see, it's a PEM type file. We'll download it, and then now I can launch my instance. Right, now I'll go to my instance by clicking over here, and let's name it as test2. Okay, right now it was in pending state, now it's in running state. So now we can connect to the instance, and but before that, what you need to do is uh, you need to download. I'll show you. Download putty software. Okay, so just type on Google download putty and click over here. Then here inside download putty, click over here, and then you need to download two things. One is the putty software for, say, right now I'm using Windows, so I'll download for Windows from over here for 64 bit, and I already have that, so I won't be doing it. You can select from here. And then another thing which you need to download is putty gen, okay, for the 64 bit. I'll explain you why we need these things. Okay, so once you have downloaded both the softwares, now we launch the instance. So first of all, let's open PuttyGen. Okay, I'll open my PuttyGen file, and oh sorry, this one, and then I load this PEM file which I downloaded. Okay, so I have this by name of test2.pem. Okay, I click on open. So it says successfully imported foreign key. Okay, right. Then we'll save this private key. It says, are you sure you want to save this key without a paraphrase? Yes, I don't want to protect it any further, and I'll make it as test2 dot. We'll take it as test2 only. Okay. So now you can see we have converted this PEM file to a PPK extension. Right. So the purpose of this putty gen was to convert our extension type, because the putty software only accepts PPK extension. So we converted it into that, and then we'll click on save. So we have successfully uh, saved that, and then Okay, now our this part is done. We'll open up putty this software, and inside this it asked me for the host name. Okay, so we'll go back to our instance. Here you can see we have all the details about my instances, like what would be my like version 4 public IP address. So this is my IP address which I was asking in that host one. I have this my private IPs, and all of these information about instances like my launch time, owner, etc. is available here. Now I'll copy this one second. Copy this version 4 public IP. I've copied it. Then I'll paste it here. Then we are connecting it via SSH. I'll click on SSH, then authorization, and then from here I'll browse my that ppk file which we just converted. Okay, so test to ppk, right? And open, and then everything is done. And then now I'll click on open. It says that the server host key is not cached in the registry. You have not guarantee. Okay, I don't mind. I'll just click on yes. Now it asks me like login as. So we downloaded Ubuntu operating system. So I'll type Ubuntu here. Now it will authenticate my that key which you downloaded, and see successfully we are now inside our Ubuntu machine. I can see that via ifconfig. It will show me my IP address details, etc. Right? So I'm here. So I've successfully launched the EC2, and now I can do whatever I want here. So so this is how you connect to the EC2 instance which has launched the Linux operating system. Right? Now we'll try out another service. Okay, I'll click over here. Okay, now let's look at the Elastic Beanstalk service. Okay, here again this comes under the compute domain. I'll click on Elastic Beanstalk. Okay, let's create a new environment. Web server environment will create. Then when I enter this create environment thing, you can see here that this it gives me like create and web app, right? So you can only create a web application here. It does not act as your backend server. It can only host your application, right? Which I explained you earlier in the services too. And I'll give my name like test2 or something. You can give any name to your application, right? Then we'll leave this this part, and it's not necessary. Environment name is already specified. We don't have this. We don't require domain for now, and we need to now select the platform, like on which. Uh, okay, and like let's say you have Java, Go, Docker, Node.js, PHP. Suppose we use let's say PHP. So my platform branch and platform version automatically selected. And now I'll just say create my environment. Okay, click on create my environment. So this will take some time, I guess. And so this was all you had to do, and now it will just start to create your Elastic Beanstalk, and it will give you access to sorry, it will not give you an access to the operating system. All you'll get is a dashboard, which you'll be seeing right now, like how it looks like and what I meant by dashboard. Okay, it will take some time. Yeah, so I had some doubts, right? Just you, yeah. For users who are working on Mac, can we work without putty? Yes, you can for sure work without putty. Uh, because in Mac you can directly connect it via SSH, right? And if anyone of you is using like Linux versions like Kali Linux or Ubuntu and all, so if while typing this command that SSH your username, whichever user you are into, @ IP, then your IP address, which you can get it from your from the IP config. So if you get error while launching it, that means you have not provided the access to connect via SSH on your system. So you need to change that from your configuration files. Okay. And in Kali, the root user does not allows you to directly connect via SSH. So for that, you need to specially go into configuration files and permit the root, SSH login in root. So now we see that our test environment has been created. Now, to check that whether it's working fine or not, what I'll do, I'll open this. So I see that yeah, we are our Elastic Beanstalk PHP application is successfully running here. So this is what I meant by a dashboard was you only get this thing, whereas in this EC2 you get uh, the like that terminal thing where you have this operating system with you. Again, you can do anything in this. Now I meant this with the dashboard, and suppose if you now this was just for the check that my Elastic Beanstalk is running successfully. Now suppose you need to uh, like you have you have a different application which you want to run. So just click on this upload and deploy, and just you have to choose a file which you want to run, and then click on the this deploy the website, and you will get your website will automatically get this deployed on this and you can check in this URL. Okay, you can visit this URL and your website would be posted, right? I hope now it would be clear, right, what I meant with dashboard in the earlier. Now let's launch our last service, for which is this Lambda. Okay, because these are the basic services. If you get a hang of this EC2, Elastic Beanstalk, then Lambda, then ECS, ECR, then you can definitely work on other services as well. Okay, so there are other various domains available here. So whichever domain you are working on, say security, you can use any of these services, right? So now let's launch a Lambda server. Okay, so here you have like what Lambda does is it just like you don't have any of these things which we did earlier. Like you don't have an operating system, neither you have uh, a dashboard kind of thing like we had in the like previous two instances. But here all you can in Lambda you can do is you just you can directly run your code over here. So I'll show you. Like just click over here, create a function. Okay, so here you have different you have author from scratch, you have use a blueprint or browse serverless app repository, right? So let's say browse serverless app repository. Okay, so here you can just see if any of the code that you want is already existing over here or not, like any of the API or services which you want to use, you can directly take from here. You don't need to write the code completely from the scratch. Okay, you have around 580 public applications. You can select from any of these. You can search from over here. It's a starter pack which was Hello World, and you can then deploy any of them. Okay, so for now, you just understand what AWS Lambda does, right? You give the code, it will run the code, that's it. You will not host an application, or you will not have the that OS kind of thing with you, right? So that's all what AWS Lambda does is. So right. So I hope guys that you are now clear with the basics. Right? Basic services. Okay, and that's it for this session. And I hope you guys enjoyed it. Thank you. And so you can, as I told you earlier, for this webinar, you'll be getting certificates from AWS Educate, and also you can fill out that form, which like link have been mentioned.